Good morning, students. Today I have to go for discussion for the memory management and virtual memory. Basically, memory means in our system we have to basically two memory things will be there. That is one memory management and virtual memory. So memory, what is the word of the memory means when we can store any information, when we can perform any task. Memory is the playing the majority role. So for that, we have the basic about memory is the two memory locations, that is a virtual memory and primary memory or secondary memory. So in the primary memory, basically we have to done any task, the basic task, whatever it will be. Like we have to write a program, we have to run a program. So this complete the temporary transaction, it will be work on RAM, and we have to perform the completion of the task, so it will be go and save in the disk or secondary memory. So for example, we have to perform any program in C or Java, whatever the programming languages. So we have to do a program where I am completing write the complete program. After writing the program, when I have to go for the execution process, so when I have to run any particular program, the particular language, for suppose I have to write addition of two numbers in the C program, after that I can go and compiling the program. So that time when it will be works, we need the memory. So at present we have to use the RAM. So in the RAM, we have to perform the basic operations. So we have to run the program. RAM will be taken the memory and it will go and check the execution process. After the execution, program will be okay. So after that, we have to save the program. So for saving process, we have to use the temporary memory or primary memory. For the basic thing is primary memory, and secondary memory, it will be go and store the information in the final disk. So this is a memory management system. Memory is manageable running a program. That is a one task. After running a program, after saving the any specific things, it will go and execution in the process. So that is the two memory allocations. In this memory management system and virtual memory allocation, it is differentiate two parts. That is in the hard disk part. That is the one virtual memory. Second one is the disk memory. So in this, we have to take the any process will be start, that is in the CPU. It will central process unit. It will be starting the process when we can open any programming documentation, Photoshop, whatever the applications. So it will be sent to the kernel. Kernel is the mediator of the RAM and CPU. So kernel will be converting the whatever the process, and it will send for the RAM. After run, whatever the process, temporary process, it will be run. After that, we have to save the file. It will go for the hard disk. So in this hard disk, virtual memory, whatever the basic process, it will be there for the virtual memory. After that, the process is completion. We can save the file that is in the disk memory. After again, we have to know the confirmation. It will again come to the RAM and come to the kernel, and after that, it will go for the CPU. So this functionality will be happening in microseconds. So why? Because we are taking to RAM write a program, and after that whatever the execution process, it will take a fraction of seconds, it will take and go for the execution. Basically, what is the virtual memory? So in the virtual memory is a storage schema, that is the provide user illustration of the very big main memory. So this is done by treating a part of secondary memory, that is the main memory. Just now I told you. So memory allocation. So in the CPU, we have to use the logical addresses and physical addresses. So logical means running application, we have to say that logical. Physical means we have in the storing in the final memory. Like instead of this loading one big process, that is the main memory, in this operating system, then the process is the main memory. By doing this degree of multiplying the differences, CPU utilization, we are also increasing. So that particular image, it will be shown for the CPU and the main memory unit and the memory management unit, after that main memory. So when CPU will be start the execution process to main memory, so in between this, we have to have the two logical address, and second one is the physical address. So it will be perform this two memory allocation to CPU allocation. And after that, what are the advantages of this virtual memory and what are the disadvantages of virtual memory? So in the advantages, come to advantages, this is user friendly and the use can be run large applications we have to perform. Means we have to write 10 lines program, we have to done 100 lines program also, it will be perform on the virtual memory. And this help of the virtual memory, we can easy to fit many large programs. We have to perform many large programs also we have to use for this. And the user can run large applications with less real RAM. And disadvantages of the virtual memory, this system becomes the slower, slice swapping take time, and it will take more time to switch between the applications. And the user will have the lesser hard disk space for its use. And the virtual memory reduces the stability of the system, and it perform the virtual memory is a not a good of the RAM. So in this, just now I told you for the logical address. So what is the basic meaning of the logical address? Where we have to use the logical address. So in the logical address, we are also known as virtual address. So in this address is generated by the CPU during for the program execution. So whenever we have to start any process, so we can go for the running the particular process. So CPU will be automatically generated for the logical address. In the basic, just now I told you for the program, whenever we have to complete the program, writing the program, and after that go for the execution process. So that time CPU will be generated the logical address. So by using the logical address, the process will be continue and go for the execution. So this address seen by the process, and it relative of the programs address of the space, and it is a logical addresses which is translated to the operating system into physical address. Uh, in this, CPU uses addresses of the references to go actual memory location. All logical addresses can create a program perspective and referred to as being in the logical address space. So this addresses is used to references to access the physical memory location by the CPU. And the time of the logical address space is used to set all the logical addresses generated by the program and perspectively. Uh, on that we can go for the physical address. In the physical address, this is everyone will be knows, whenever we have the laptop or system, we have to communicate with the, like it is using for the Wi-Fi basis also physical address will be available, and the cable basis also the system will be have the physical available. And every system we have the physical network is available. Why? Because it will be like by using the at present we are using in the active fiber, and some government sector we are also using for the a network like BSNL network. So that time we have to provide the fixed network, we have to use a physical address. So by seeing the physical address, we have to give the numbers. For suppose I have the 10 systems in my college. So in the 10 system, I need provide each and every system providing for the physical address, system number 1, 2, 3, 4. By using this, we have to use, that is we call it as MAC address. So every system, and in the system network, we have to providing for the logical addresses for the temporary basis, physical addresses for the permanent. So, for example, in this image, it will be represent the physical address, that is the number 080027 and 7286 and BB. In this, just now I told you for the 10 systems, the numbering will be in the B of the places 01, 02, 03, 04. So like that 10 system will be there. I am giving the each and every system, and every system they have the own network address. So that is the physical address. So in this physical address that helps to identify the physical location of needed data known a physical address. We cannot use physical address directly. We can use only access by corresponding the logical address. So whenever we have to communicate for the generation of the, it will we can use, means in the physical address it will be have one place. So by physical address we have to use, for suppose I have to open the Google browser or Chrome browser. So this particular browser opening time, it will be collect the information for the physical address. Automatically the system will be generated for the logical address, and it will be perform the task. Why? Because connection is the one part. After connecting the physical address, it will be communicate for the CPU. After CPU we have to use it and go for the process whatever the applications we are running. And so that is the physical address, and this image represent for the CPU and main memory. In this CPU and main memory, it will be one is the logical address. After that logical address, the relocated register means new process will be starting. In the new process reallocation register, it will be take the help of the uh, logical address, and adding with the physical address, it will go and send for the main memory. And these are the two differentiate things for the logical address and physical address. The logical address, it is a virtual address which is generated by the CPU, and physical address, it is located in the main memory unit. And the users can be easily view the logical address of a program, and the user never view the physical address of a program. And the logical address is the space of set of all logical addresses generated by the CPU in the references to a program. And the physical addresses is a set of all physical addresses mapped to the corresponding logical address. And so the user uses the logical addresses to access the physical addresses. This user can directly access the physical address. So in the logical address, it is generated by the CPU, just now I already told. In the physical address, it is computed by using the main memory unit, MMU for main memory unit. So memory, we have to allocate it, and it will be like cable basis or Wi-Fi basis. It be physical addresses is the mandatory. And in the logical basis, after getting the physical address, after that it will be performed, come to the real time we are using for the logical addresses. And the next topic we can go for the swapping. In the swapping means switching two persons, we can use one way. So swap the materials. For suppose we have two person will be communicating. So this particular two persons will be communicating, means whenever I have to give someone the particular process, after that particular process we can giving some input. After that, the particular person will be give the another response. That is the we have to receive the process. So sending and receiving is the major part of the swapping. So in the swapping is the main memory management technique. It is a temporary swapping process from the main memory to the secondary memory, or vice versa, which help to the increasing the degree of multiple programming and increasing the main memory illustrations. So this purpose of the swapping in operating system is to access the data present in the hard disk, and so many applications in the program we can use it. And the thing of the remember of the swapping on use it in the present. So swapping mainly it will be performed on the RAM only. And in this they have the two operations will be performed. One is the swap in and swap out. So the method is removing a process from the secondary memory, that is the hard drive, and the restoring is to the main memory for the RAM for execution is known as the swap in method. And the swap out means it is a method for bringing out of the process from main memory, that is in the RAM, and sending the secondary memory hard disk. So that process with higher priority or main memory consumption will be executed, known as swap over method. So in the swapping, the execution will be sent to the hard drive, secondary memory. But in the swap out, it will be sent for the RAM, and the set is the primary memory, and it will be sent again to the secondary memory, that is in the hardware. So that is the two process will be higher priority or more memory for consumpting will be executed as known as swap out method. So this is a basic image. What are the inner operations will be performed in the swapping. So that is when on the operating system, the user space will be there. He can give one instruction to the process one, and the secondary memory there have the two process will be running on. So first the process user operation will be sent for the swap out. So it will be go for the secondary memory. The process one will be running on that. The process two again it will be performing on that. So process two will be switching to the user. So one is incoming and another one is going outside. So execution is a step-by-step process. So okay process we have to perform one task. Again, it will be sent for the another process. So it is sequentially using the memory, and it will getting the memory and using very less time, and we can give the effective output. So that is the main intention for the swapping the process. So when we can swap the things, large number of files also getting the easy to execution, and easy to execution means we have the lot of time will be saved. And so the third one is a continuous memory allocation. So continuous memory allocation, it is the one of the major memory allocation strategies. And we can use this kind of the strategies to allocate the continuous blocks of the memory each process. So it is already there is a most and we allocate for the segmentation from the entire empty area of the process based on the its size. Whenever the process to go for the execution, the process will be continuously means whenever the process 10 process run line up, so whatever the process, that is the process 1 2 3 4, so each and every process on particular time it will go for the execution. So continuously it will go for the execution, and continuously memory allocation will be going on each and every person. We have to take 5 process, so each and every process they need 1 KB memory, 1 KB memory. So for that execution, the 5 process will be there. So first of all, first process will become and it will take the memories 1 KB. Second, third, fourth, five. Each and 5 processes I am allocating the 5 KB memory. So in this memory, whenever the process will be starting, each and every terms and conditions will be accepted for the process go and executing. So the completion of the time and memory allocation, it's everything will be okay. Continuously memory allocation will be done. 5 process memory allocation will be done. After that, the process will be success. Or any changes, like some process will be take last of time. Some process will be take some higher memory. So that time we have to get some error allocation or delay for the process. So this one continuous memory allocation, we have to use two continuous things. That is the one is fixed size priority schema, and second one is the variable size partition schema. Also in the fixed side means just now I told you for that I'm fixing the memory. In the 1 KB, that is a fixed memory. It will go for the execution and it will take the 1 KB memory only, which will get for the execution. So there is no new adding the things. It is not possible. Fixed means where allocation 1 KB means in the 1 KB memory only it will go for the execution. So this type of the continuous memory allocation techniques, each process is allocated for the fixed or continuous blocks and in this main memory. So that is the mean we will be continuously block of fixed size into which is complete the memory will be divided. Each process is a process come in, it will be allocated to the free blocks. And so this is the fixed memory, and the variable size priority schema. So it is the variable size of the partition schema. There is no fixed blocks, means just no way allocated for the 1 KB for each and every process. But in the variable, we need some more memory. We have to use it and we have to get complete of the task. So these are two priorities we have to perform. So this is the advantages. We can easily, simplistically, we can perform the task. Easy to manage. Why? Because memory allocation will be already fixed. Means we have to easy to complete the task, and effective allocation. Why? Because we are giving the memory particular time, and the transaction every process will be time and efficiently work out. And disadvantage is limitation flexibility. For suppose just now I told you 1 KB, so it is very limitation. That is the one disadvantages. And in inequality partition sizes. Why? Because sometimes memory will be required, some memory allocation will be done, so we cannot perform. So that is the one drawback. This is image will be represented for the fixed size. So each and every process I'm giving the 5 MB. I have to use the 3 process. So but the requirement of the process one, it will size is 3 MB. So it will go for the execution. And so this is the allocation. Each and every memory, they have to given 3 process. So each and every process required 3 MB, but I allocated for the 5 MB. So 2 MB will be not used, 3 MB will be used. Why? Because it is a fixed. For suppose it is crossed for the 6 MB, so automatically the process will be hold on. And this is a variable memory, that is the efficient memory utilization, and it is also fixable, and reduction for the internal fragmentation. And disadvantage for this, increasing the complexity and higher overheaded. And so this is the process where I am allocating for the same process operating system fixed partition.